Thank you for attending. So functional programming languages are all the rage. All of us in this room probably know that that's not necessarily the solution to all the world's problems. But still, there are certainly some features of functional programming that are desirable. And what I'm going to talk about is how we could add those to Smalltalk and end up with something quite usable. So my name is Dave Mason. I'm at what is now called Toronto Metropolitan University. Until a month ago, it was called Ryerson University in Toronto, Canada. But we changed to be politically correct. So first of all, I want to have a short quote from Kent Beck about software creating value by what it does today, but also what it can do tomorrow. And Smalltalk is even more applicable here. So Smalltalk already has many functional features. In fact, some people would argue that it is one of the first languages to have functional features because it had closures. Except they weren't proper closures for a long time in all contexts. So what I'm going to talk about today are two kinds of extensions to this. One is extensions of syntax, and the other is extensions by adding methods to various classes to make more functional programming convenient. So first of all, I'll talk about the syntax changes because they're the most, in some ways, the most interesting. The others you could probably figure out yourself fairly easily. So we have blocks, and now they're full closures, have been for a while in most Smalltalks, but that's critical because you can't really do functional programming if you don't have full closures. So I implemented a while ago and finished implementing last night, or actually this morning at 3 o'clock. A compiler extension that works with Pharo that called Compile with Compose. And it basically mimics the compiler, extends the compiler in a few ways to support the syntax changes that I'm going to talk about. And this is not rocket science, but it's not for the faint of heart either. If you're not comfortable with parsers and scanners, you're going to find it challenging, but it's certainly in the realm of doable. And so the idea is that in Pharo, and I suspect in most Smalltalks, you can choose to use a different compiler. In Pharo, all you have to do is declare a class-side method and say what class you want to be your compiler, and off it goes. So that's what I'm using for this. All the changes in the syntax here are just syntactic sugar. So I use the existing AST, I put things into the AST, and so on, but I don't touch anything deeper than the AST, and all the methods that I use are just the standard methods that are in the system. And it's just syntactic sugar because it makes it more succinct, makes it easier to express sort of a functional style of programming. And they're all upward compatible because this will not break any code that you have because it uses what is otherwise illegal syntax. So all the operations here are illegal syntax if you don't have the compose, compile with compose class installed and you're not using it in your particular class. So the first thing, I'm not sure how many people here have done any, like, more than a sample 10-line program in a functional programming style, functional programming language. Okay, so about half. So one of the things that is quite popular in functional programming languages, what's called, so one of the things that's very common is to take the result of one calculation and then pipe it to the next calculation, pipe it to the next calculation, and so on. This has been popularized by Elixir and Haskell as well. And versions of it are also popular in the JavaScript world. So this is the first operation, the first syntax addition, and I call it the parrot operator because it kind of looks like a parrot on the side. And what it does is it pipes the result of the left-hand side, and that becomes the receiver of the right-hand side message. So this expression takes 17, negates it, and then the result of that takes a min with that and minus 53, and then it takes the result of that and gets the absolute value, and then result of that compares it with 100, ands it, and again, and then if true, if false. So all these, so if I didn't have this, I would have 7 left parentheses before the 17 and lots of parentheses gathered in. So that's all this syntax change does, is it just rearranges the AST so that so we don't have to write all those parentheses. But it has exactly the same effect. So this produces 42 as a result, not too surprisingly. This is particularly convenient in Pharo.js because some JavaScript libraries use this extensively. There's a great graphics library called D3, and each transformation gives you a new result that you want to pipe to the next value, to the next value, to the next value. And so this is really convenient in that context. The precedence of this is the same precedence as Cascade, so you can actually intermix them. I don't know whether that is particularly nice thing to do, because this is pretty weird code, but that is the precedence that I set for it so that you can actually do that. And it maybe is useful in some cases. Yep.
On the previous slide. So why do you have to modify the compiler for this?
Because colon greater than or less than is, like there's no way to do this except for putting lots of parentheses. So this is 7 parentheses, 17 negated, close parentheses, actually you don't need it around that one, but then min and close parenthesis, then abs, then less than, and so on. So there's lots of extra parentheses that you have to do otherwise.
But in the current compiler, the colon is detected for block variable arguments for end of keywords. So so it means something already. The colon cannot use any selector in Pharo currently. You cannot use a
So the question is, why do I have to change the compiler to do this? The answer is that colon is not part of a valid binary operation.
Yeah, but you know, I think that we have thousands of binary operator that we can generate it. Once I did a script that takes all the stupid characters, French character, and generate.
Yes. The other problem with that is that there are keyword operators in there, and you'd have to put parentheses around all of those. So yes, if you've got a string of binary operations, yes, you can do it. You don't need this. But if you have keyword operations, you need to do this. Otherwise, you need to put parentheses.
I get it correctly. So it means that we could have a variant without changing the compiler by just choosing another selector, and we pay the price to put parentheses around keyword.
All the keyword operations.
Okay.
But then there is the precedence. The precedence is different.
Right.
Yeah, the precedence is different as well. So.
That is the point, is to have it's a binary selector that has more precedence than less precedence than the keywords.
Yeah, lower precedence than keywords.
That is the only change.
The goal is to get rid of the parentheses.
In Haskell, you can change the precedence per selector.
Okay. So I have probably too many slides, so if I don't mind answering questions, but so if you don't want to do this, I have a version called Chain, and other people have done a similar thing where essentially what you do here is you use Cascade, and this works, except that it does a DNU and a perform on each cascade. So it's way less efficient, but because the other one has no cost, it's just parentheses get inserted. This one has a significant runtime cost. So another popular thing in functional programming is what's called point-free programming, where you take functions and you combine them into new functions and combine them into new functions and so on, and where you don't really express the parameters explicitly. And there are various combinators that you can do. If you've programmed in Haskell, there's the dot combinator, there's the $sign combinator, and there are a few other combinators. There are in fact a whole other spectrum of combinators that are interesting for this. In Smalltalk, the functions that we have are blocks and symbols. So I've generalized symbols somewhat to make this work better with those. So for example, this is a creation of a new function. So the angle bar angle operation takes the left function, applies it to the to the argument once, and then uses the right function and uses it with the original value and the changed value. So what this does is it takes the parameter madam, reverses it, and then checks to see if it's equal to madam, equal to the original. And so this gives you, is this a palindrome? Okay? It's something you have to, it's an acquired taste. I'm not a huge fan necessarily, but it is, it can produce some very succinct code. To use point-free style, it's very convenient to be able to express this rather than having to say value all the time. So here's a more succinct syntax. So basically, you can use a parenthesized expression in operator position, and it will do the equivalent in the bottom. So it gives you a value, but back to Steph's point, it doesn't require extra parentheses because it doesn't have a value colon keyword function in the middle. So it gives you a much more succinct way to write code. For binary messages, as you can see in the third line, there's a colon after the parentheses because there has to be some way to recognize it as a binary operation. But that colon is not a keyword operation, it's part of that binary operation. So you can compose it like any other binary operation. It has the precedence of a binary operation. Yeah, Steph?
Sorry to be dumb. I don't understand what is dot dot dot. And
some expression, any expression. So it could be something like the reverse composed with equals.
okay, so can you maybe just continue?
Well, I'll show you examples later on, more examples later on. Okay. You can also do the same thing with unary or binary blocks. So you can put a block in operator position, and it performs the equivalent of doing a value. And again, it just saves you the noise of the value keyword and the parentheses. Sorry? It uses value at the moment, but it could be curl instead. Or sorry, call instead, yes. Yep. Except that it looks at the arity of the block, because this is a literal block, so it can look at the arity so it knows that it's a binary. So if it's a unary, it uses value. If it's binary, it uses value. Okay, so that's may or may not meet your taste. This is something I personally find extremely frustrating about Smalltalk, is that when I declare variables, I would like to initialize those variables. I don't want to be changing them. I don't want to be declaring them and then assigning values to them. I find that very annoying. So this syntax lets you do that basically at the start of a block or the start of a method. In the declarations of a set of variables, you can include initializers. And the Y version is intended to be immutable, and the colon equals, the equals version is immutable. Colon equal is mutable, And this is a la Newspeak. Newspeak has the same syntax or similar syntax. And I have not implemented the immutable one yet. Marcus and I were talking yesterday or the day before about how to do that, but I did not get a chance to implement that yet. So this is very, very common in functional programming. In fact, in functional programming, frequently people do no mutation, even in languages where they can. They just do a sequence of declarations and build up the values as they go. Yep.
Why is the second one not legal?
Because it doesn't know whether 17 is being ORed with something or whether it's the end of the declaration. So you have, if you do this, you have to complete the expression with a period. Yep. Sorry, can you make this multi-line? Yes, certainly. There would be no restrictions on that. If you had this, you might actually want to be able to do a sequence of declarations at bars at the beginning of your code, and that could look quite nice where you'd said X is assigned something, and then on the next line, Y is assigned something that perhaps uses X. That, I think, would be very readable. And so basically what happens here is when it's parsing the declaration, if it sees an assignment, it adds the assignment to the start of the block that it hasn't actually seen any statements for yet. Now this was one that I think a lot of people would like. Arrays have a literal syntax with curly braces, but other collections don't. And so what this does is if it sees a colon immediately after the open curly bracket, it expects the next thing to be a class, and it is going to send it a with or a with or a with up to 6, because that's all there are in the Pharaoh image at least. And then beyond that, it turns it into a with all and generates the value that you'd expect.
I wonder whether, you thought about having the same feature here, but without extending the compiler, but using some message. Like if I send the set message to the array, it will say, okay, .dnu, go get to the something like this.
So the question is, did I think about possible ways of doing it without the syntax changes? Well, you can always do it as saying as dictionary at the end, but that is going to create the array and then send it to the dictionary and do it with all. And so it's going to create a data structure that then turns around and gets just garbage collected. So this is more efficient.
Wait, this one, we should really integrate it in Pharaoh.
Well, you should integrate all of these in Pharaoh, but thank you for the positive comment. Now, the other thing is that it's very frequent to want to be able to deconstruct structures, and this is common in functional programming, where you return a tuple or a pair or something from a function, and you want to have some way to deconstruct it or destructure it. So colon bar becomes a part of its valid expression, and it basically, whatever kind of collection it is on the right-hand side, sends it appropriate messages. So that code on the top gets turned into the code on the bottom, except the temp variable is one that you will not conflict with. And so it evaluates the right-hand side, and then that right-hand side gets sent a first named and the name of the first variable, second named and the name of the second variable, and so on. And so arrays just have first named is equivalent to first, second named is equivalent to second, and so on. For a dictionary, it uses the first named is equivalent to at, and so on. Yep.
And this is yet again a one stroke for initialization of all of these, because usually in a functional language you have just an array with instance variable in there, and then you can destructure the right structure to the left structure.
So yes, so the question is, more or less, did I consider having a function, or sorry, an array structure on the left-hand side as being a way to do this? Syntactically, that is much harder to parse because you have what is a valid expression, and then it's much harder to figure out what I'm supposed to do with this. This is quite straightforward to parse.
Okay, but just a question. You know, in Python, for example, they do that, but on method return.
No, you can do it for any expression.
I mean, do you do it also on method return?
Well, you could have your, you could create a pair or something like that. So I have pairs and tuples, so you could create a pair and then
What I was
deconstruct it.
Okay, I will try to say it correctly. So if I define a method and I said, okay, this is a method that expects 3 arguments, but this is I write 1 argument.
Ah, I see.
So will I write? Oh, what do I write at the end? See what I
So if you got one argument and you wanted to deconstruct it in the method, then you'd do this at the beginning of the method. But no, I didn't add any syntax to do that automatically. I don't know how you would do that automatically, but
Because this is what they do. No? In Python, they do that.
no, not quite.
So how do they do it then?
They create so they have a variable argument. So the question is, in Python, they do something like that. How they do that is they create essentially a dictionary. The compiler automatically creates a dictionary if you have more parameters than it knows about. And then it deconstructs it out of that dictionary. Okay, so those are the syntax extensions that I have, and I had to modify about a dozen methods in the parser. So my compiler extends the standard one, and it defines about a dozen alternative functions.
Before we go there,
Yep.
we play once with an experience of can we have default value for argument? You didn't play with that?
No, I did not play with that.
I'll show you a bit what the idea that we had, and also optional keyword messages. You know, instead of having
Okay. Perhaps we could talk about this offline because I have 6 minutes left and I'd like to show. Sure. Okay. So then I added some new classes and a variety of extension methods to facilitate functional programming. So curry basically takes a block or a symbol and a value and concatenates them together. So it creates a new block that has the, so these are just functions, not syntax, or just methods, not syntax. So it returns a block that fills in that value in the appropriate place. So if you say a block at a number, then it composes it as the block taking the number as the right-hand side of another function. If you do it on the other order, then it treats it as the left-hand side. This is in a language like Haskell, for example, you can write 3+ in parentheses, and that creates a function that will add 3 to whatever parameter you pass. I looked at doing that for syntactically, and it's really, really messy to do just in general. I couldn't figure out how to do it in anything that was going to look reasonable. Plus, I think that this is a perfectly reasonable alternative. Although, syntactically, it wouldn't have to have any overhead, and here it has overhead because you get back a block that has to be evaluated. So I extended symbol. Symbol always had value, but it now has value colon, or value, and so on, as well as col, which means that you can treat symbols and blocks symmetrically. I added map and map for block closure and symbols, and all these are collect in the opposite order. So they're just very convenient. And yeah, for someone coming from a functional programming world, being able to map some kind of function over an array or a collection is much more natural for them. We saw the angle, bar, angle combinator. There's a whole bunch more that are implemented for block closure and symbol. Nil or, basically, if you've got a non-nil value, it'll execute a block. If it's nil, it just returns nil. So it's very convenient if you have a sequence of values that you want to pipe using the parrot operator, where you calculate something, and if it's nil, you're fine, you're just going to skip the rest of the calculations. But if it's not nil, you want to do something, then you want to do something else, and so on. So it builds on things very easily. There's pair and tuple, which are just what you'd expect. Collections, but they're immutable collections, and they're useful for returning from functions and things like that. Zip collection just takes two collections and treats them as a single value, but if you use map over, then it will pass the two values to each of the values, or to the block each in turn. Slice allows you to take a piece out of the middle of a collection, a sequenceable collection, and treat that as a collection. So you can just sort of take a slice out of something and pass that value on to somewhere else. They're immutable by default, but there's a mutable method that you can send them that will make it mutable, so you could change it that way as well. You can also reverse it. You can do all the operations you'd expect. Zip and the zipper operator are just to create zipped collections. IOTA just produces a sequence. It's the equivalent of an interval, but just done a little bit more directly. And then there's all sorts of algorithms on collections, rotate, slide, products, and so on. Okay, so I have 1 minute left to do my demo, but perhaps I have a little bit of flexibility on that. Okay, so I'll just quickly go through test cases. I'll skip over this one, actually, and grouping. Is there things like grouping by runs, where you've got a collection and you want to group them? There's a couple of new and more flexible ways of doing that. Checking to see if a collection all has unique values, those kinds of things. Scanning over them, applying an operator over them pairwise. Here's an example of slice, where you take a collection, you take a slice of it, and then you can do various operations on it, just like it was the original. The advantage of doing this is it doesn't make a copy of it. It's just a reference to the original collection, and so if you have a large collection and you use slices over it, you don't create all the garbage that you would if you were doing it otherwise. Value. Okay, let's look at functional test. Just a couple of these are interesting, just some combinators. So here's an example of curry, which might make that clearer. So you say 5 at minus produces a function that will subtract something from 5. So when you pass it 4, you get 1. If you passed it, and it doesn't matter which side it's on. So the first line uses the value version of it, and the second uses it as an operator expression, but does the same thing. Okay. Cycle, product. Sorry?
It's the original Smalltalk syntax, isn't it? It's not the syntax you showed before.
the first one is the standard syntax. The second line is the operator. Yeah, 4 open parentheses, so that parenthesized operator expression. Just showing it that you could use it either way. Cycle product, so product just does a product, see equivalent of sum. We have sum, we don't have product, I don't know why. Replace is interesting, okay. But the more interesting would be to look at the compile with compose test. So here are array literals, or the other literals, dictionaries, sets, tuples, pairs. I think it's a very natural way to create these things. Here's an assign with declaration. So, so you can see that A and C are still nil as you'd expect, but B is not. And fortunately, the compiler or the display system actually shows me that these have not been initialized. But don't the one that was initialized. Here are block operators. So here I have a unary block, here I have a binary block, and so this one just takes one argument on the left, this one takes a left and a right argument. We saw this before. Here's destructure, where I just have, and so the first example I have a destructure, but I also assign the whole thing to W as well. So it just works like any other kind of assignment.
Dave,
Yep.
I was thinking, is it extendable? Can we add with other things than existing? I mean, it should be a class or the sets for dictionary, for instance, the dictionary creation,
Yep.
creation. Is it any class, collection class, or is it?
It doesn't care what, it's any class that understands with, and or with all.
And if not, it does say that runtime?
It does that at runtime, yes. It just takes the class and just says, how many things are you initializing with? If it's less than 6, it uses one of the withs, and if it's more than 6, it uses a with all.
But Dave, why we cannot just do with all? Like
Because you can, but it's going to create a temporary array and then throw it away. Sorry?
The literal. What's the literal in these things?
There's no array literal being created in these. It uses with, and with, and so on, up to 6.
The dictionary is not created at compile time. That's it. I think that they would expect that if it is really literal, actually, you can actually compute it at compile time and store it.
No, it's not at compile time, it's at runtime, but it's done the most efficient way possible. In other words, there's not extra garbage created. There's only the dictionary created. There's not a dictionary, an array, and then a dictionary.
Yes, so you end up with the actual code is like dictionary with this is what you need.
Yep, yep. That's another using parrot operator, another with parrot operator. Here's parenthesis operator examples. Yeah, we don't need those. And I think that's it. So I'm going to go back to my slides just for a moment. Yeah. Okay, and it has to do with this. Of course it does. And I don't know where it is. Okay. I've lost my presentation. Okay, so we'll turn mirroring back on. Sorry about that. So this is the how you use this. It's all available on GitHub. And just do Metacello. Oops, you can't see that now. There we go. So Metacello, and then for any class hierarchy, you can use the compose syntax trait, and you get it. Or on the class side, you just define a compiler class method and return compose compiler, and it works for you. The second approach, you could put this on object, and then it would work everywhere, including in the playground. Otherwise, it will only work in the classes that you actually do it in. So Smalltalk already has the fundamentals for this, and some syntactic sugar can make things a lot more pleasant. I'd like it, obviously love it if some of this became mainstream, and because there's no backward compatibility issues, nobody can say, oh, but it's going to break my code. No, it will not break any valid Smalltalk code. None of it will. And you can add to your Pharaoh image. And the compiler tweaks for a compiler person are not that hard to do. As I said, it's about a dozen methods I had to change. But it won't work anybody else because nobody else uses the Opal compiler. So any remaining questions? Yep.
Is it integrated somehow with the debugger, or do I then see value statements?
The question is it integrated with the debugger? I have not done any work to integrate it with the debugger, so you would see, I don't know what you see actually. I haven't stepped through to see what happens if you step through, but you will definitely go into the value. It has to do go into the value. I may not have done everything properly in terms of showing where the beginning and end of expressions are and so on as well. That's also possible. So, you know, I wanted to get the functionality there and make sure that that was working. Yuche.
A couple of easy questions. Why tuples and pairs, and why not arrays? So what is the difference in API?
Sorry?
Why tuples and pairs and not arrays?
Why tuples? Slightly more efficient is the answer, I think. So the pair, for example, is just, it's the equivalent of association. Like it just has two fields rather than having an array inside it. So I think it's probably a little bit faster, but.
And also about the slices, I really would like to have slices eventually. Besides immutability, are there other concerns that you took into account?
So the question was, are there any other any concerns around slices? One of the issues is because it is a map on an underlying data structure, if you modify the underlying data structure, you might be surprised that your thing changed, and vice versa. But that's why I make them immutable by default, is because most of the time you don't want that. You want to, what you really want is, I've chosen a piece of this and now I want to be able to hand that around as a proper collection and not have to mess with it. So I think immutable is mostly what you want, but I realized as I was doing it, well, you might want mutation because it's actually a really efficient way to get into the middle of something, or really flexible and easy to think about way to get into the middle of something. Yep.
You have a slice on the living stuff. If you modify the collection, the slice update, and then you can say, no, I want to pay the cost, freeze, and then means that you get the cookie.
Sure, you could very easily do that. I mean, that would be a simple operation. You just go and get the piece from the collection immediately, make a new array, and make that be the collection that you drive off. Yep, be trivial to do. Yep.
So actually, what does it finally, apart from normal syntax? So where you have the additional power which comes now from the functioning there? Most things was just a syntactic choice and saving some of the rest of this.
So what it does is it lets you think about things more as data that I'm passing to something, that I'm passing to something, that I'm passing to something. And I mean, that's what functional programming is just data gets, you apply a function to data, and then you apply a function to the result, apply a function to the result. It's just, it's really just syntactic sugar. I mean, in a language like Haskell, you can't mutate things, but in Scheme, for example, you can. So functional doesn't mean you can't mutate things. It doesn't mean there aren't side effects. It means that you are used to programming in terms of functions being applied to functions. And being able to initialize things is like any functional language person that came to Smalltalk and said, I'm going to do what? I'm going to declare variables and I'm going to mutate them? Just to start off? That's insane. Why would I do that? Why wouldn't I just say, here are my variables and here are the initial values for them? And I probably won't change them, because I'll probably calculate them sequentially on the fly. So anyway, I don't know how much time I should eat into the next person's.
We can have discussion.
Does this mean that I can now, using the parrot operator, avoid putting parentheses around the and before the if?
Yes?
Yay!
So the question was, does the parrot operator mean that you can avoid putting the and before an, parentheses around an and before an if? And yeah, it should. I haven't tried that, but I'm pretty sure the answer is yes.
Just because I could not really understand in the 10 you have assignment and then you have equality.
Right.
I just want to tell you a story. My wife is learning Python and then I had to explain to her, oh, equal, no, this is not the mathematical equal. Equal, this is the assignment.
Right.
And then after she told me, oh, and how do I do equality then? Oh,
You say it twice.
equal. So in that case, for example, for you, I will not use equal for, I will use tilde equal or something like that, but don't
Right.
overload equal with something else.
Sure. So I haven't actually implemented that, so that's an open question. So the question was, why would I choose in the initializing where I wanted it to be immutable, why would I choose the equal operator? The answer is that's what Newspeak does, and so that's where it came from. That doesn't mean it's right. So I would make it : equals as a much clearer way of saying this is an immutable binding. And in fact, you could make it so that was legal anywhere, not just in declarations. So anywhere I said : equals, you'd mark that thing as immutable, and you couldn't modify it in the rest of the, or that variable name as immutable at least, so that I couldn't modify it later in the method. But
So about the constructor, so does it have to match the size of the collection? Can you ignore some elements like
yeah, you can ignore elements. So the question is, in the destructuring thing, does it have to match the size of the value that you're matching? No, it does not have to match. It just sends that thing a first named or second named, third named, fourth named, up to 9. You can't have more than 9 because that's all I defined. But so it'll send 9th named foobar and.
You should limit to 3, you know? After they should create an object.
Sure. Yeah, so it's a collection, and it doesn't. So no, you don't have to match everything that's in it, and the values do have to be there. So it will call first named or whatever. On the other hand, you could make third named return nil if it's less than that or something like that. I mean, you could do. I didn't do it. I throw an error, but any other questions? Thank you.